Hello everyone. Welcome to the solution of LeetCode problem 779 named kth symbol in grammar. In this problem, we built a table of n rows, which is one index. Now, we start by writing 0 in the first row. Now, in every subsequent row, we look at the previous row and replace each occurrence of 0 with 0, 1 and each occurrence of 1 with 1, 0. Suppose, for example, for n is equal to 3, first row is 0, second row is 0, 1 because we replaced 0 by 0, 1. And the third row is 0, 1, 1, 0 because we replaced 0 by 0, 1 and we replaced 1 by 1, 0. Now, given two integers n and k, we have to return the kth symbol in the nth row of the table of n rows. Here, k is also one index based. Now here, let's consider the example 1. Here, the value of n is 1 and the value of k is also 1. So here, we have only one rows, so the output will be 0. Now, for input n is equal to 2 and k is equal to 1, we have two rows and we have to pick the first element of the second row. So the first element of the second row will be 0, so we have to return 0. Now, the second element of the second row will be 1, so we have to return 1. So here I hope you understood the example. Now the constraint are, the value of n can be in between 1 to 30 and the value of k can be in between 1 to 2 to the power n minus 1. I hope you understood the constraint. Now let's move on to the algorithm. Now, before jumping to the algorithm, let's try to understand and figure out some of the pattern. Here, initially we are given a value 0. Now, we have to replace each occurrence of 0 with 0, 1 and we have to replace each occurrence of 1 with 1, 0. Now, the value 0 will be replaced by 0, 1. So for the third row, the value 0 will be replaced by 0, 1 and the value 1 will be replaced by 1, 0. For the fourth row, the value 0 will be replaced by 0, 1, 1 will be 1, 0, 1 will be 1, 0 again, and 0 will be 0, 1. Now, for the fifth row, 0 will be 0, 1, 1 will be 1, 0, 1 will be 1, 0, 0 will be 0, 1, 1 will be 1, 0, this 0 will be 0, 1, this 0 will be 0, 1, and this 1 will be 1, 0. Now suppose if we have to find the value of n is equal to 4 and the value of k is equal to 5, we have to find the fifth element of row 4. So here, the fifth element of row 4 is 1. So now, this is one example. Now, did you really notice some of the pattern? Let's see. Suppose for this first half, suppose we divided the last row by 2. It is first half and it is second half. Now, this first half is exactly equal to this previous row element. And this second half is exactly opposite its previous element. How do so? Because you see, the first half element is 0, 1, 1, 0, 1, 0, 0, 1. And the previous element will be 0, 1, 1, 0, 1, 0, 0, 1, which is exactly equal. Now, for the second half, the value will be here 1, 0, 0, 1, 0, 1, 1, 0. So here, the value 1, this 1 is exactly opposite to this value 0 here. this value 0 is exactly opposite to this value 1, and so on. So we can say that the second half is completely opposite to the previous row. So far, so good. So did you find actually a pattern here? So the pattern here will be, if the value of k is less than or equal to the mid position, then the value is exactly equal to the previous row. Suppose, let's try to understand this condition first. Suppose the value of k is 6. It is pointing to this element 0. So now 6 obviously less than is equal to the mid, which is this position. So here, for this array, the sixth element 0 is exactly equal to the previous array's sixth element, which is this. So this is the first condition. Now, if the element is greater than or the value of k is greater than the mid, now what will happen? Suppose the value of k will be 10. So 10 is indicating this position too. So here, if the value of k is greater than mid, then we can see that the value is exactly opposite to the previous elements and k minus half element. Now let's understand this. Suppose the value of k is 10 here. So the value 0, it is marked as the position 10. Okay, so far so good. So now the value 10 is greater than the mid position, which is this. So as for this row, the mid position is 8. So here we can say that this value 0 is exactly opposite to the previous elements or previous rows k minus corresponding mid value element, which is 10 minus 8, which is 2. So this value 0 is exactly opposite to the second element of the previous row, which is this value 1. So this is one condition. Another condition. Now, if we run a recursive solution and each recursive call, if we do the bottom-up approach and try to find the base case, we can solve this problem by using only these two logic. Now, let's try to understand how can we solve this problem by using a recursive algorithm. So, as we all know that to perform a recursive algorithm, at first, we have to find the base cases. So, what is the base case of this problem? The base case of this problem is if the value of n and the value of k is 1, then we have to return 0. So here, if the value of k or the value of n is equal to 1, then we have to return 0, which is this element 0. Now suppose, let's try to run a recursive algorithm. Suppose we call a recursive function f and the value of n will be 4 and the value of k will be 5. So we have to determine the fifth element of the fourth row, which is this. Okay. Now we have to check whether the algorithm is, we have to check whether the value of k is less than is equal to the 2 to the power n minus 2 or not. Now let's see. The value of k here is 5 and the value of 2 to the power n minus 2, that means 2 to the power 4 minus 2 will be 4. So we can say that 5 is greater than 4. So this condition is not met. Okay, in this position, we have to recursively call the function on the value of 3 of n, which is the previous row, and here the value will be 1. Why it is 3 and 1? Or why the value of n is 3 and the value of k will be 1? Let's see. Initially, we have called our function on this position, right? So this 1, 0, 0, 1 is exactly opposite to the this 0, 1, 1, 0. So now the call will be into this position. So this value 0 is exactly opposite to the this value 1. So we have to flip the bit. That's why we are using a NOT operation. And this value 0 is the first element of the corresponding third row. That's why the function parameter is 3 and 1. So far, so good. Now let's check whether the value of k, which is 1, is less than is equal to 2 to the power 3 minus 2 or not. Yes, it is, because 2 to the power 3 minus 2 will be 2. So here we can see that the value of 1 is less than or equal to 2. That means this value 0 is presented before the mid position. So here we have to call this function on the previous row and the corresponding k. Here the value of k will be unchanged because this position 0 and 1 is exactly equal to this value 0 and 1. So now the call has been transferred to this position 0. So here, now let's check another thing. The value of k is still 1. Now let's check whether it is less than is equal to 2 to the power n minus 2 or not. Here the value of n will be 2. That means 2 to the power 2 minus 0. So here it will be 1. Less than is equal to 1. Yes, definitely it is. So here, now the call will be into the function of previous row and the corresponding k. Here, the row is decreased by 1, but the k is still unchanged because this value 0 is presented before the mid position. So now the call is in the top position 0. So here, this is the base case. From this 1 and 1, we have to return 0 to the caller function. Now 0 is transferred here again to the caller function, but this function will flip the bit. So now this will return the opposite of 0, which is 1. Now this main function will return the value 1 to us. Now, surprisingly, we can see that for the fourth row, the fifth element will be 1, which is this. This is how the recursive solution works. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named kth grammar with the value of n and k. So here the base case is if the value of n or the value of k is 0, we have to return 0. Otherwise, we have to check whether the value of k is in the left position of the mid value or not. If it is, that means we have to recursively call the function on the previous row. Here, the value of k will be unchanged. And otherwise, we have to recursively call the corresponding function with the previous row and subtract the value mid to the k position. And finally, flip the bit. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.